laser pointer. This isn't rocket science, man. It's like 4 buttons.
I know, but it's not. But it just does. It's just broke.
It's like 4 buttons. I didn't get 4 buttons.
That's oh, I guess we just.
We got to start.
Yeah.
Do we have a note?
I did not know. We usually put up the.
I need a note well.
Yeah. Is there one on that?
Yes.
We can do every other one too.
No matter how I try to prepare.
Yeah, I know. We were here.
There's always something.
Okay. You can start it out.
Okay, everybody, we're going to get started. This is the LSR working group. Maybe, Alistair, could you shut that door? No. So you're the farthest forward. Okay, so again, this is the first meeting, the first session of the LSR working group. We left off a note well slide, so this is the note well from the most current version. Do I need to read that?
No, you don't need to read it. Everybody's asking questions.
Does anybody need me to read the note well slide? You stop nodding your head. Okay, so we're going to move on to the agenda, to the status slides. So, Casey, go ahead.
Okay, I'll go ahead. Actually, I'll stand up and do them so you can see better. Okay, I'm going to try and go through these quick. We had a very prolific third of the year and got a lot of these RSCs published. I do have the one, the OSPF V2 extensions. That was actually a VIR document, but the other ones all published. Granted, most of them are pretty simple extensions, but it was nice. There's a thing there. It has nothing to do with Chinese food. The one in ISIS, the MSG, that's MSD too. Next slide. Okay, so we have a lot of these. We have the ton encapsulations draft still waiting more than a year now it uses the IANA registry and the BGP document. There's a lot of BES and BGP documents, probably a half dozen documents depending on this. And it's being presented tomorrow in IDR, and hopefully we can move forward to publish it. We also have the OSPF and OSPF v3 extensions, and we're waiting on the interop with LDP draft and the MPLS data plane segment routing draft. Those are both spring documents. And I'm hoping the former, I think the former is almost done. The latter, I'm not sure. The interop with LDP. LDP is missing. Next slide. Okay, the first one, the HBIT support, that's been waiting on the offers. They promised me something this week.
Yeah, so actually we have updated the draft, but we missed the deadline, so it will be done soon. So
it's open right now. It opens up.
Okay, I can.
It opens when the IETF starts.
Okay, all right.
Okay, so you can update it, and we can ping Elbaro and let them know this comments.
Okay, all right.
ISIS extensions now we'll have all of our LSR documents for MPLS data plane segment routing will be once we satisfy. We got 2 of them on the RFC queue waiting for misrefs, And this one, once we get past Alvaro's review, he just gave us comments in the last week or two. We'll have them all done, and we'll be ready to start on other flooding and other documents. We have these two Yang models. They're waiting on AD to review. They're kind of big, but they should be all right. They've gone through several Yang doctor reviews. And I just requested this cross-address family publication for that one. Next slide. This is in working group last call. I'd encourage everybody to review it. This is the more deterministic restart signaling for ISIS, similar to what we have with OSPF. So you can do like a pre-planned. You can request graceful restart procedures prior to restarting. And we believe these two are ready for a working grass call. We have the intent to do them. They've been around quite a long time. There's, at least for the OSPF one, there's some implementation work. I don't know about ISIS. I'm not sure, but I know we have OSPF. And next slide. Okay, we're looking for both these two, ISIS and OSPF, the ELC drafts. Shao, who's not here, but I think Stefan's going to update these. And we actually have enough changes. We'll probably do another working group last call. I haven't talked to the authors, but at that time we may think about combining them into one, since we're going to do another working group last call anyway. Next slide. And flex algorithm, there's some implementation momentum. I don't think we're ready for working group last call yet, but it's just moving along. One thing I did, I talked to the IDR chairs after the first IDR session, and especially for some of these simpler extensions, they'd like to have us allocate an IANA code point for BGPLS and do it in the same draft. So you don't have, for every extension in ISIS and OSPF, just like we combined some of the drafts with ISIS and OSPF when they were really exactly the same extension, just encoded a different way. In the same spirit, we'd also define the BGPLS code point right away. And we got these two Yang models for SR. Now that we've got these base, I think before we did anything, we're just going to at least wait till we get through the AD review on the base Yang models before we try and working group last call these. But we're going to do that shortly after that. All right, next presentation. Yeah, we've been pretty busy as far as discussions, and we're going to have updates on at least the first two of these drafts. These are the more significant ones. The other two are sort of protocol maintenance that we approved. One is a request from the PCE working group. We already have PCE discovery, just an extension on it to also discover the authentication that the PCE server. At the moment I can't remember the name. What is it? PCE what? Yeah. To learn the MD5, but I was thinking of the difference between the client and this. Do you call it the PCE? That's the client. Yeah, for the client to discover the server's security. And that's it.
Yeah, so I guess the sort of big thing that we managed to do is get everyone to mostly agree to the resolution with the dynamic flooding.
Yes.
So
and that's a good safety.
Yes. So Tony, I think you're up.
Good morning. So I'm very pleased to report that we have accepted the dynamic flooding draft as a working group document. We have...
There's no page.
Oh, sorry.
Let's see. I happened to show some friends some of our simulation results, and they commented that they wanted to see a whole lot more of them. So have some of those to show you. Thank you, Mr. Scudder. We have two outstanding issues. We've already discussed a little bit on the mailing list. These are the question of how fast do we add temporary additions to the flooding topology when we realize we've had a partition. And then also, are we going to include lands in the flooding topology as an explicit part of the topology description? We've had that hashed out a bit on the mailing list, but have not come to consensus. We, this week, had a little lunch and arm wrestling match between the parties in having the discussion. We think we have come to rough agreement there, and we will return that discussion to the mailing list to achieve consensus after IETF. On with the pretty pictures. So just to show the flooding topology on some simple dense graphs, this is K5, the complete graph on 5 nodes. The dotted lines show the links that are excluded from the flooding topology. So you see that this is already winning about 50%. Next slide. K10, this is a full graph, a complete graph on 10 nodes. As you can see, this is already having wonderful effects. Right? Most of the links are no longer included. As we scale upwards, next slide. This is K160, 160 nodes, and very Spartan. Next slide. Some of you are interested in leaf spine topologies. This is a leaf spine topology with 8 spines and 200 leaves. And as you can see, it looks dense, but actually this is very sparse. This is like 95% of the links are blocked.
Does this flooding topology have 2 ways to get to everything, all these simulations, or 1 way?
Everything is bi-connected. The diameter is constrained, and also the degree of each node is constrained. So what that means here is that all the spines are equally loaded. Next slide. We also were interested in looking at CLO topologies. This is a 3-stage with 16 top nodes, 64 middles, and 160 leaves at the bottom. As you can see, the algorithm does all sorts of weird things, but turns out a beautiful picture. Okay, next slide. There are topologies where the algorithm doesn't do pretty things. This is an 8x8 grid, just a chessboard. And as you can see, the dotted lines are relatively few and far between. This does not work very well. Why not? Well, it's not a dense graph. The problem that we're trying to solve is flooding on dense graphs. When you throw this on a graph that's not dense, it doesn't help very much. Doesn't hurt, and that's actually more of the point for our testing, is to show that the algorithm doesn't break anything, but it doesn't really help very much. Okay, next slide. So just to recap the 2 issues that we have outstanding, temporary flooding. So when we realize we need to add temporary flooding onto the flooding topology because we have had a partition, then there are 2 opinions. One's, do we add as much stuff as possible? And some folks favor this because it minimizes the convergence time. We want to get the flooding topology back to covering everything as quickly as possible. That's certain. So do we just turn on all of the links and see what happens? Flip side is, well, if we add on too many links, we can recreate a catastrophic collapse. And obviously, that's got infinite convergence time, so that's not good. So how do we do this so that we don't trigger that? and therefore the conservative approach might be to add links very slowly. Again, we're going to continue discussing this on the mailing list, but those are the two prevailing opinions.
So no one's asking for the Goldilocks solution.
Well, everybody wants both, of course. And nobody has proposed something that gives us both. The second issue is putting pseudonodes in the flooding topology. Currently, as the draft reads, you cannot describe a LAN as being part of the flooding topology. This gives us some topological constraints. If we do have a flooding topology that might include LANs and the area leader cannot describe it, then you might get a topology that is radically different than what the area leader intended. And that could be a problem. I think we've come to the agreement that if LAN is in the flooding topology, that all nodes should be flooding to and from that LAN. Because selective flooding gets really complicated really quickly. So then the two opinions that have been put forth on the mailing list, either we put all LANs on the flooding topology, and this makes everything very, very simple, or if we have too many LANs, that seems like that could be problematic, so we need to be specific. And that allows us, the area leader, to describe exactly what should and should not be on the topology. So again, we'll have that discussion continued on the mailing list. That's all I have. Any questions? Thank you very much.
Not quite fast enough in my old age here. Dave Allen from Ericsson. I'll just speak up. Do you have any information on the diameter of the flooding topology relative to the type of graph?
The question is, do we have any information on the diameter of the flooding topology relative to the original graph? So that is algorithm specific. In our implementation, yes, we constrain the diameter. We definitely increase the diameter. Okay, for a complete graph, the diameter originally is 1. As you can see, the diameter in the graphs that we generate much higher. So that, of course, causes increased flooding time. But we do have a diameter constraint in there, trying to minimize the diameter because we don't want it to go unbounded.
Okay, thank you.
AC Lindum, I got a quick one here. I definitely agree that you would not want to do anything on a LAN but flood, basically because you have a designated, a DR or a DIS. It's going to be flooded to all the nodes. You don't want to change. You don't want to touch that. But wouldn't it be algorithm specific, just whether you made, how you preferred LANs and how you didn't? I don't see why you'd need to. Maybe I don't understand the problem. I don't see why you'd need to put all LANs on the flooding topology if the algorithm didn't need to put them all on.
So the real question is whether we are allowed to specify LANs in the signaling of the flooding topology. Okay. If you can't specify it, then no matter what your algorithm happens to do, there's no way to say. So do we have the specificity in the actual description? Any other questions?
I just want to test. Okay, so the mic is working. Good. Sorry.
Going once, going twice. Done. Thank you.
I think it's less, right? Yes. Yes or less.
X. This is
Fine.
Is this, yes, but is this the alignment where can't see the whole slide?
Sorry.
Anyways, I'm Les Ginsberg, talking about the spine leaf draft. Next slide, please. So this is just a summary. We've presented this before, kind of an overview of what this draft achieves. It's a modest extension to ISIS. So in spine leaf topologies, using these modest extensions, you can get a great reduction in the amount of flooding. Basically, what we do is, in most cases, we completely eliminate flooding to the leaves entirely. We also have some support for zero-touch provisioning, where you can advertise your tier and discover it. We do have provisions to handle what you end up with basically from the leaf nodes is default routes to the spines, but in cases where spine nodes don't have full connectivity to all of the leaves, we have provisions to get a subset of the more specific routes that are required so that we don't black hole things. And we have hooks so that extensions like the flooding topology that Tony was just talking about, we can advertise that the links to the leaves are not being used for flooding, so the algorithm can know what those links are and just basically take them out of the calculation of the flooding topology. Next slide. So what's happened since the previous version? We became a working group document. We had some comments about some of the information that we were allowing to be sent in hellos. We've simplified that and split it. We had one TLV, now we have two different TLVs. I'll talk about that a little more. And we've reintroduced support, some limited support for connection, leaf-to-leaf connections. Next slide.
Can I throw a comment in here? So when this was actually a long time ago, you had this leaf-to-leaf support, and it was the one place it kind of scared me, where there was possibilities for like loops. It seemed like, right? Did you guys? I mean, do you think you addressed? Did you see that as well? And do you think you addressed it?
Yes,
Okay.
but I'll talk about some more,
Oh, okay.
so you can ask a more specific question. Okay, so we have a spine leaf TLV in the hello, which does a couple of things. One, it allows you to advertise your tier if you are able to discover it. And there's a bit that just says the tier field is valid. If that bit's not set, whatever value is in there is ignored. And then we have two flags, one of which is sent by the leaf node that says, hey, I would like to be part of the reduced flooding, which means I don't want my spine node neighbors to flood LSPs to me. And we have an R bit that's sent by the spine nodes that indicates that they can be used as a default gateway. This TLV previously had additional information, which we've moved into a separate TLV. So now this is the information that's the only information in our extensions that's sent in hellos. Next slide. We created a new TLV, which we call the leaf set TLV. And this is going to be sent in circuit scoped LSPs as defined by RFC 7356. And there are currently two sub-TLVs that we've defined associated with this TLV. We have a leaf neighbors sub-TLV, which is sent by the spine nodes. And that indicates the set of leaf nodes to which this spine node has connectivity. This information is useful to the leaf nodes. They could compare the set of leaf node neighbors that each spine node advertises and therefore detect that, oh, gee, this spine node neighbor that I might be using as a default gateway doesn't actually have reachability to the full set of leaf nodes. Next slide. The second sub-TLV in the leaf set TLV is sent by the leaf nodes. So in the case I was just talking about where the leaf node discovers that, hey, there's a spine node, I was using him as a default gateway, but he doesn't seem to have full connectivity to all the nodes. The spine node can send a request, or the leaf node, excuse me, can send a request to the spine node to say, could you please send me prefix reachability information associated with this set of leaf nodes. So it's just a list of the system IDs of the leaf nodes, which he's retrieved from the sub-TLV that we showed on the previous slide. The spine node will then respond by sending, and again, in the circuit scoped LSPs, he'll simply send the standard prefix reachability TLVs, such as 135 and 236, to the leaf node on request, and say, okay, here are the prefixes that are associated with that leaf node, and that allows the leaf node to install more specific routes to those destinations. Next slide. Okay, as Chris's question highlighted, in early versions of the draft, we had connections between the leaf nodes. There were some issues raised with that. We took it out. But there are deployment cases where people would like to be able to send traffic directly from leaf to leaf. So we put this back in, but I think I've jumped ahead of myself here. Yeah, sorry, you got me.
You want me to jump forward a slide?
No. Sorry, I was just thinking we're about to go to that. I'm sorry, back up. Let me get to the slide because this will. We've introduced two bits. One of them is new to this version of the draft. That's associated with an existing TLV, the link attribute sub-TLV that was defined by RFC 5029. I've listed here all the bits that are, including the ones that are currently defined. So there's a local protection and an excluded from local protection. Those were defined many years ago. The two new bits, one of them is sent by the spines that says, hey, I am connected to some leaf nodes that want to be excluded from flooding. And this is one of those links. And that tells an extension like the flooding topology, the optimized flooding topology that says, hey, you don't need to consider this link as part of your flooding topology. That's been defined for some time in versions of the draft. The new bit that we added in this new version of the draft is sent by the leaf nodes. And this bit just simply indicates I am connected to at least one spine node. And you'll see how we use that. Now you can go to the next slide. So again, we put back in the ability to support leaf-to-leaf connections. We're recommending that you only have one leaf neighbor because there are some consequences of having many. Largely, it means you're going to increase flooding unnecessarily. One of the things we want to do with the leafs, we're trying to keep the leaf implementation fairly simple. So we're not proposing that the leaf node do any kind of special logic associated with flooding. So if you now connect, if the leaf node is not doesn't have any leaf node neighbors, he simply sends his own LSPs to the spine node as he normally would do. But now if he has a leaf neighbor, he's going to get the LSPs from that leaf neighbor. Unless we define some special rules in this case, he's also going to send those LSPs to the spine. So the spine's now going to get, in this case, spine 1, for example, would get LSPs from leaf 1, both from leaf 1 and from leaf 2. Obviously, you start having lots of leaf neighbors, you've increased the amount of flooding. So we're recommending that you limit this to one leaf neighbor, which I think from a deployment standpoint meets the common deployment cases. There are two modes that the leaf-to-leaf connection can be used in. We really only want, if you only want to use the leaf-to-leaf connection for local traffic, then the leaf node will set the overload bit, in its LSP, which tells the spine node, do not use me for transit to any of my other neighbors, and in particular, my leaf neighbor. If you want to allow transit traffic in the case where, let's say, I'm a leaf node, I got isolated from all of the other spine nodes. So the only way now for a spine node to get traffic delivered to me is to go through another leaf node. So in this case, you don't want the overload bit to be set, but you want this to be used as the link of last resort. So you set a high metric. We're recommending max metric -2. And this makes this the link of last resort. And I think that's it, or yeah. So that's the update, and we welcome comments.
So I think the earlier issue I had to look, it was like almost 2 years ago, but it was like if you had, you were like defaulting over to the leaf, but then you could have a better metric back, or it was something weird like that. I guess
yeah,
you considered that.
I'd have to go back to the versions, but I don't think we ever talked about setting the overload bit before,
Mm-hmm.
and I think that addresses that problem.
Yeah, and so this would be for both leaves, so everything would be configured in the same mode.
Correct.
Yeah.
So what I guess I missed it, that there was this big a update. I haven't read the update. Sorry. So the overload bit, when a leaf gets isolated, the other leaf would have to the leaf that's still connected would have to reset the overload bit.
Yeah, this is not meant to be a dynamic setting. This is like, how do I want to use this link? If I only want to use it for local traffic, then I set the overload bit. If I want to use this as the link of last resort in case I get isolated.
Okay.
Yeah.
I see, I understand now. I thought this was when it got isolated, it would change. Okay, makes more sense now.
Yeah.
How many have read the update? One. Okay. About 4. I advise everybody to read it. This has gotten a little more complex than it was, but not too much more. But I'd advise everybody, including myself, to read it.
Yeah, I mean, it's always fun to find loops, right? So they might be hiding here still. So go looking. No bounty, but.
One reason we adopted this is because it seemed like a limit. It seemed to address data centers, and it was a lot simpler than a generic flooding. We said, okay, we can do this, and we can do something more generic. So I'm hoping it's not getting too complex. Once you cleared up the thing with leaf being a static configuration, makes it more understandable.
Yep.
Okay, thanks.
Okay, this draft was introduced in Bangkok, and I'll just be reporting on the updates. I think probably the biggest news or most welcome change for me is we got some additional authors. Next slide. So what were the motivation for this? Largely had to do with, we've seen in the field some interoperability issues in how implementations handle TLVs, which are either unrecognized or disallowed or incorrectly formatted. When we had inconsistent behavior where LSPs, some implementations would discard LSPs, some implementations wouldn't, and you end up with link state databases that are inconsistent on routers in the network, which really leaves the network in a broken state. There's been enhancements a few years ago in terms of how purges are handled, and these have backwards compatibility issues, and that played into some of the scenarios we've seen in the field as well as far as interoperability problems. So those were the major motivations. Next slide. Okay, what's changed? Again, additional authors have been added. In the course of reviewing the draft with the new authors, we discovered an IANA registry issue, so we're addressing that. And we've added a recommendation about controlling behaviors that are not backwards compatible. Next slide. So the registry issue, RFC 6232, some years ago, introduced this purge origination TLV so that you could identify the source of a purge, which is a very important thing to be able to do in troubleshooting some problems in networks. The text in the draft was absolutely correct. It said this TLV should be found in all purges and must not be sent in an LSP, basically a non-purged LSP, an LSP with a non-zero remaining lifetime. Unfortunately, the IANA section in this got put into the actual IANA registry. The flag for the LSP, that is the non-purged LSPs, got set to yes, and it should have been no, so we're correcting that. So again, the text in the RFC was absolutely correct. It's just the setting of the flag in the registry was not. Next slide. There was also a discussion. We thought it would be prudent to recommend that when you have transitions to new behaviors that are not backwards compatible, that we recommend that implementations put some controls in as to when to enable that. One example, not the only example, but one example of that has to do with the introduction of the purge origination TLV. If you look at the cryptographic authentication as defined in 5304 and 5310, it was very strict. It said the only TLV you can have in a purge, if you have cryptographic authentication, is the authentication TLV. When we introduced POI, that obviously meant there was at least one additional TLV that could legitimately be found in a purge. So implementations which are following 5304 strictly, as they should, would then reject a purge that had a POI. So you need to be careful as to when you enable this behavior. If you have cryptographic, that is the use of the purge TLV in the presence of cryptographic authentication. So what we've added to the draft is just a recommendation that says in such cases, it's prudent for implementations to provide controls for when to enable this. Next slide. So I have to say that this has been, amazingly enough, and quite surprising to me, this has been the most popular draft I've ever written. Whatever that says. We've gotten a lot of support from this. There's also this, we published yesterday, we actually published an update to this based on the comments we had received from Bruno. It's mostly using more clear language. No real addition in terms of the substance of the draft, but hopefully it's more clear. So we think this is ready for working group adoption.
Does anybody in the room disagree with that? Yeah. Okay. Thanks.
Okay.
I mean, we'll ask on the list if anybody objects as well, but it's kind of an obvious thing.
Peter?
Okay, so I'm Peter from Cisco. So I'm going to just give a quick update on the SRv6 ISIS extension draft. So we just added a single new flag in the locator TLV which basically indicates that the locator is used as an anycast one. One reason to do this, because there are applications where you don't want to use these sits from the locator, which is an anycast one, for example, for a TLFA, where you really want to enforce the traffic over a certain node. So that's the use case. That's the bit we added. Next slide. And we also updated the table in the draft, which refers to the supported endpoint behaviors which are advertised by ISIS. It matches the latest network programming draft, and it also includes the endpoint behavior identifiers, just for clarity, so you don't need to go and look to another drafts what the identifiers are. So other than that, the draft is stable. There are implementations. You can go to the next slide, please. There are multiple implementations available, even working together. So I think this draft is ready for the working group adoption. If there are any questions, please feel free.
Yeah, I'll ask, how many people have read the draft? Yeah. How many people were sort of following the spring network programming? That adoption's about halfway through. There's a lot of support and some discussion about other issues, but I think we're going to ask for an adoption call on this one, especially if the immediately after the network programming is adopted in spring. We were sort of waiting for it. They asked for adoption last in Bangkok, but we delayed until at least the network programming call for adoption. Okay.
Okay.
That's good.
Okay, so the next one is the OSPF v3 extension for beer. Next slide. So we have RFC 8444, which describes the OSPF v2 extension for beer. With MPLS encapsulation, we need the same work to be done in OSPF v3, so this is the draft that deals with that. The flooding scope and all the machinery in the protocol is exactly the same as in the RFC 8444. So next slide, please. So just to recap what we
starting to work.
Yeah. So what we defined the BR sub TLV, which is carried within the prefix. So it uses the new E intra and E inter area prefix LSAs to distribute the BR specific information. I mean, the fields in the sub TLV are exactly the same. I'm not going to repeat them as in the OSPF v2 extension. This is a sub TLV of the BR TLV, which carries the MPLS specific information for BR. So again, I mean, the fields in the sub TLV matches the one in the OSPF v2. So this has been presented in the BR working group. I think they're going to own the document, if I'm not mistaken. So the adoption request is basically going to be here. I'm presenting here because it's an extension to the IGP. So if you guys have any concerns, just let me know and we can work it out.
So when we chartered beer, they wanted to go on a fast track and own all the documents, and we agreed that they could own these extensions in beer. So it makes sense since OSPF and V2 and ISIS are in beer, it makes sense for this one to go there as well, especially since this is just using the extended LSAs. The reason we didn't do OSPF V3 before was because the extended LSAs hadn't been published yet. Now that it's published and we have implementations, we're going forward and finishing that work.
That's correct.
So I mean, it'd be nice if, it'd be good, especially if OSPF implementers and people who debug and deploy OSPF v3 networks would review this. Thanks.
Mr. Les Ginsberg. So I'm just asking, does that mean there really is no working group adoption request here?
No, it's in a BI working group. That's correct.
Are you using the same slide presentation?
Yes. Obviously. Sorry? I didn't catch it. The tags, yes. Okay, so the last one is the extension for OSPF to advertise the admin tags. So, okay, this works. It's not working anymore.
It looked like you came up with a program.
Okay. All right, so a little bit of a history. In OSPF v2 and v3, we had a way to send a tag, the admin tag with a prefix, but this was only limited to certain prefixes, namely the external and NSSA prefixes. We didn't have a way to advertise admin tag with the intra or inter-area prefix. And we were also limited to a single one per prefix. I mean, we all know we have different use cases for tags. We use them for the distribution, for prefix prioritization, and there are various use cases for these. So what we actually are proposing is that we are adding a new tag sub TLV for either the extended prefix TLV in OSPF v2 or an intra or inter-area or external prefix TLVs in the extended OSPF v3 LSAs. What we also added is the tags for the links. I mean, whether that is something that we want to do is up to the discussion, because we have the SRLGs where we can actually advertise similar 32-bit values for each link. It's up to the working group to decide whether we want to do it for prefix for links as well, but the draft itself proposes the extension to be able to associate the admin tag with the prefix or a link. Okay. All right, so I mean, the TLV is pretty simple. It's a bunch of 32-bit administrative tags in a sub TLV, so it's pretty simple. We've seen this before. So the draft also says about how we are going to propagate the admin tags between the areas and during the translation. It also says how to behave during the summarization, where we are not going to advertise the tags of the component routes. Go to the next, please. And it also says that if we have a tag associated with the external or NSSA LSA in the old-fashioned way, we prefer that because we want to be backward compatible. And it also goes into the discussion that there can be multiple tags associated now with a prefix, etc. So what are the behaviors that we can use? So, I mean, in a nutshell, this is a very simple and natural extension. We want to have the possibility. It's mainly, I mean, the way I look at it is for the inter-area prefixes to be able to tag them and, use this. I mean, we have the similar capability in ISIS. So I guess it makes a lot of sense to adopt this and move forward.
Les Ginsberg. I'll ask a loaded question here. Have we made a conscious decision not to support 64-bit tags?
I put it in the appendix of it because I found no implementation of 64-bit tags in ISIS.
Yeah,
I asked a lot of people, and nobody knew of one.
Yeah, I'm in complete agreement with that. I just wanted to verify that we've consciously made that decision.
Stefan Nikowski from Orange. You were talking about adding tags to links. What was the use case you were targeting to that? You pointed SRLG, but we have also admin groups, which could be also similar.
I mean, We didn't have any particular use case. We just thought, if we are adding this, whether it makes sense. Again, I don't have a strong opinion. We put it there. We can remove if people think there's no use case for it. I don't really know.
Yeah, I think we have sufficient mechanism today to tag links.
Fair enough.
As a co-author, I would agree as well. I did this draft a long time ago. There was no burning requirement for it, and we had full working group agendas and things that we needed to get in front of the working groups. So we kind of delayed it. We had 2 sessions. Said, okay, now's the time. There's nothing too contentious until tomorrow, and so we put it on the agenda. We said, okay, let's try and socialize it. But I agree. Now we did. So we had this predated our whole discussion of attributes.
Okay.
Okay.
Okay. Not the link tag. I think we can take it out. Well, I think it's Ketan, as he's known as in the IDR working group. Hopefully, I won't get in trouble for that. It's going to work. See if you can get it to work.
Hi, Ketan Talaulikar, Cisco. So this is an update on the OSPF reverse metric draft. Just a recap, it was presented in London. It was just named differently back then. And we have equivalent functionality in ISIS already. We also have a OSPF 2-part metric draft which covers kind of similar capability, or at least can be used for the use cases for broadcast LAN. So what this draft essentially does is brings this capability for point-to-point links and other types. Reminder on what the draft is. It enables OSPF router, and it's applicable for both V2 and V3 to signal to its neighbor the reverse metrics. So it's a metric that a neighbor should use towards the link to this router. And this is done in a link local signaling mechanism using the LLS block in hello messages. When the neighbor receives, in this case R2 receives the reverse metric signaling, then it may use that value, or we have support for offset as well as value in its router LSA towards R1. So this mechanism is link local, so it works. It's really between routers on a link, and it's kind of transparent to other routers in the network. So for this, we have introduced the reverse metric TLV. What's the new update in this draft is we have also included the reverse T metric TLV because this was something that was not covered, and there was no support for. We had missed the multi-topology ID, which was not there in the previous version. So that's the other update that's been introduced. Apart from that, there is really no significant change in the document except for some editorial updates, which was pointed by reviews and so on. So we're looking for working group adoption of this draft at this point. Any comments?
How many have read the draft? Don't count. A few have. Yeah, we'll discuss it a little bit on the list, the use cases. I know one of the use cases is the same use case that the large packets are in BFD. The L2 VPN where where you don't know the characteristics of the underlying L2.
Yes.
That's one of the use cases, and that's the same.
Yeah.
Same motivation.
So does anybody object to possibly taking this on as work? No. There was nobody.
So this one is OSPF introducing BFD strict mode. We just had a presentation of this earlier today in the BFD working group, and this is something that we have in multiple implementations already. So what we're trying to bring out here is to define it more formally, let's say, and to see how it helps in some of the interop issues and consideration. So the problem statement here is that BFD is being used by OSPF for detecting faults in the forwarding plane and primarily detecting it fast and bringing down the adjacency. However, a BFD router does not know as part of its signaling whether its neighbor has support for BFD. And as a result of this, the BFD OSPF adjacency is brought up without considering whether the BFD session is brought up or not. I mean, it's brought up independently. Now, in some scenarios, we have seen or we have observed issues where the OSPF adjacency may come up, but the BFD may not come up, even though BFD is enabled on both sides of the link. And this could be because of some problem in the underlying path. Now, this could be for various reasons, including transport, lossy links, degraded links, so on and so forth. And what this results in is, even though the OSPF adjacency may come up and we advertise it in routing, the traffic over it would, get affected. As well as in case of lossy links, you may suddenly find sometimes OSPF adjacencies also flapping. So that's a churn that is introduced in the network. So what the draft proposes is really to enable OSPF router to signal to its neighbor that it's running BFD, and B, that it does not want to bring up the OSPF adjacency unless the BFD session is up between them. So which means that the BFD has verified the bidirectional connectivity, and only post that we try to bring up the OSPF adjacency. And this is what we are referring to as BFD strict mode in this document. So there is a similar extension in ISIS 6213, and it's kind of similar functionality that we are doing. So how are we doing it? We have in the OSPF hello messages, we have the link local signaling block, and in there we have a TLV which allows, it's called the LLS extended option and fields flags field, which allows routers on the link to indicate capability to each other. And we've introduced a B bit there, and this B bit indicates support or capability, or let's say interest to operate in BFD strict mode. Now, the BFD session establishment, when the two routers detect each other, they are supporting this BFD strict mode, then as soon as the new neighbor is detected, BFD session is requested immediately. And the key thing is there is some, we're trying to clarify in how to do this fit it into the OSPF neighbor FSM. And the proposal is that the neighbor is held in the init state until the BFD session is up between them. What that also means is that the router does not include the neighbor IP address in its own hello until the BFD session is set. This essentially will block the adjacency or the neighbor's FSM to move into a two-way next start. So the moment the BFD session is up, include the hello neighbor address in the hello, and then the FSM proceeds as exists today. So there's no change after that. For backward compatibility aspects, this mode is going to get employed or come into action only when the two neighbors agree or exchange this capability. And this is only, if it's not there, then the OSPF neighbor FSM goes like existing today. And the only change is in this initial bring up. So it's basically the transition from init state onwards. The rest of the neighbor FSM is unchanged. There is also no change in the way BFD is used to bring down an OSPF adjacency, handling of BFD down events, all of that. Nothing is changed from that perspective. So a little more details on the BFD part. So this is again only changes are in the initial bring up. There's also more details and text in the draft. We try to cover scenarios where this capability or this option is turned on for an adjacency which is already up, and there the proposal is that we do not disturb an adjacency that's already up; it just continues. And removal of BFD or the BFD strict mode also does not disrupt adjacency that's already up. So next steps, we are aware that multiple implementations have this kind of a feature support already, and the way it's been done is with kind of explicit configuration support. But we've had some cases with interop where it's not really clear at what state in the neighbor FSM, let's say, an implementation should hold the neighbor and how it should go about it. So it also makes troubleshooting difficult in that aspect. So we're looking trying to see if a working group is interested in standardizing this, and would appreciate feedback, and comments.
So you found incompatibilities out there with I understand that there's no standard. But.
Yes. So the key aspect of interop issues is where the neighbor FSM is held by an implementation until the BFD is brought up.
Is it actually functionally broken when they don't agree?
So there are two parts of it. One is that we don't know whether the neighbor is strict mode enabled. So the first way to get working between, let's say, two implementations is that both have this explicit configuration, and then they bring it up. Now, in a case like a LAN, for example, where there are you may want to do it between two routers, but not with the third one is not capable. So that's a provisioning aspect. Then within the bring up as well, when the BFD session cannot be brought up due to some errors or whatever, we see the neighbor FSMs. We do not even see a neighbor, let's say, on one router, and we see it on an init or a two-way state or something. It becomes difficult to figure out what's happening or where this is at.
So I guess where I was going with this is, it's interesting you've already discovered this. Do you cover these cases? Like, it might be interesting for an appendix or, for deployment, right? Like, if this is deployed, this is how it will interact with these various, non-interoperating, and these are the results that we currently have with these, non-specified, non-interoperating things.
So it's not there in the draft, but what we added some text is to describe, operation in kind of like operational consideration, what all information should be shown or what logs and all should be done to reflect the state. And, if the neighbor is not going beyond in it, why is it not going?
Yeah, I mean, I'm saying it's interesting. It would probably be interesting to list the interop issues you found that you'll be fixing by having this.
Sure. I mean,
it doesn't have to be extensive, right? But.
Okay. Sure. And mainly look forward to inputs from other implementation. I'm not sure if there are implementations which are doing this differently, but we would like to get feedback on that.
So let me understand it. So if you get a hello and it doesn't have the strict bits set, you just don't use BFD as a precondition and just commit and just go as normal. Okay. And then if the bit flips anytime once the session is past a net, you just ignore it. You just keep going.
Yes.
Okay. I mean, that's kind of a subtle, that naturally falls out nice in the implementation. That's where it would be really nice to talk to some other, get some other implementers that want to do this, to collaborate and make sure that
yes. So definitely need feedback and inputs there.
Okay, thanks, Ken. Wemo.
Is this okay?
We don't know if it's going to work.
We have to see if it's
okay.
We don't. I don't know why it comes up on here. Okay, that's a good one.
Good. Okay, it works. So I'm Huai Mo from Huawei. Today I'm going to talk about distributed flooding reduction. Basically, I just talk about the updates in this version. So in this version, we removed the centralized flooding reduction. And then we also updated distributed flooding reduction to get instructions from the leaders because of this remove. And then we added a scheduler and a consistency check. So first we talk about scheduling. So scheduling for flooding topology computation. So there's a new RFC talking about scheduling for SPF. So right now, for some network, we have multiple schedulers. I mean, in a network, normally we have the routers from multiple vendors. So the routers from one vendor may use one type of scheduling for SPF, and some of routers from another vendor may use another schedulers for SPF. So the issue is that using different schedulers for SPF will create more routing loops than using the same scheduler. So this is talked in very detail in these new RFCs. So as we know, so that suggest the best practice is that we configure similar timers on all the routers. So in this case, we want to have SPF to be triggered at almost at the same time. But sometimes it's impossible. So here, one example is that for consecutive SPF executions, if we have two different schedulers, then it's almost impossible to have SPF on all the nodes to be triggered at the same time. So here, we just have two examples of two schedulers. So one scheduler is that we just schedule SPF in constant delays. For example, first SPF delay 200 milliseconds, and then second consecutive runs 200 milliseconds, and then the third one and so on. So this is constant delays. So another scheduler is that we have initial delay for the first run, And then for the consecutive run, and then we use a hold off time. For example, is maybe 100 milliseconds. And then the next one, the hold time will be double the first hold. And then if we have another run, and then the delay time will be double the first delay. So if we have these two kind of schedulers, so it's almost impossible to configure whatever time to have those SPF to be triggered at the same time. So this new RFC expect that we have used same schedulers, but the reality is that for those schedulers for SPFs, we already implemented. So we have no way to at least no way to do that right now. But for scheduling for flooding topology computation, so right now we have is a good point. Is the right point. We need to have use the same schedulers for scheduling the flooding topology computations.
Wimo?
Yes.
I might be in the minority, but I don't agree that you can compare FTC and SPF. I don't think they're the same thing. I mean, I don't think they require, FTC requires a scheduler like some as because you don't update ribs and fibs and it's all internal to the protocol and it can be done very quick. But you can go on.
I know.
So I might be in a minority, but I don't think you need it.
Yeah, it's a good question. I think about that one. Because if we use different schedulers, so the flooding topology will be different.
Right. I don't think you need a scheduler for this.
We don't.
You just do it as soon as possible, as fast as possible.
Yeah, that's another way. I think maybe the better to have a scheduler and then with a control because we can control the timer to make it faster.
Okay.
Yeah, yeah, I agree. Yeah, that's what we can.
Okay. Quick comment here.
Everybody else wait. I'm sorry. No.
Can I? It's Peter from Cisco. I completely agree with AC. You don't need any scheduler here.
Yeah, that's what we can argue about that one because it's better to have a scheduler at least because if we have consecutive computations and then may have some issues there. So with a scheduler and then we can have control. So if we can configure those time very smaller and then looks like we can achieve that one, right?
Yeah,
very fast.
So since the can has been opened, I don't like this either. But my dislike of this is we've been able, I know there's an RFC there, but we've been doing ISIs for a really long time without standardizing and on-wire TLVs to specify when timers should fire. This seems like a big overreach, and it just doesn't need to be specified. There's other things that I like in this draft, but this is not one of them. That's as a working person.
So another, because we right now this draft is focused on distributed flooding reduction. So for distributed flooding reduction, we need to get instructions from the area leaders. So we need so after operator configure the distributed flooding reduction, then every node must receive the leader sub-TLV. So in this leader sub-TLV, we have indication which algorithm will be used, and also should be indication of a distributed mode. And then, so we also should have received those kind of parameters for the schedulers if those configuration is done on the leader. So the last one is about a flooding topology consistency check. So for flooding topology, because flooding topology is computed by every node, so one node, flooding topology computed by one node, so must be the same as the one computed by another node. So if two flooding topology are different, and then the inconsistency occurs. So we need to have some way to detect this consistency and handle it accordingly. So here we just propose a very simple way. We just define new bit in the hello, extended hello. We call the flooding topology bit for a link. So for each end of the link, each end node of the link. So when this node have a line topology change regarding to this link, they just change that bit. So if two bits are the same, and then regarding to this link, the line topology is consistent. If they are different, and then we for a given time, it's different for a given time, and then we think this line topology is not consistent regarding to this link. So we can give a warning, and then on the other side, two sides, maybe if one side think is not on the topology, maybe we just temporarily assume that one on the topology. That's about the consistency. And I think that's all.
Maybe I could provide some color in that. I'm sorry. Thank you so much. I'm Sue Hares. Most people know me as a IDR chair. That's not what I'm proposing right now, but that'll give you a place to find my email. So, two things on this one, just to provide some color in some research I'd done on why this problem might be useful. One of the deployments for IGPs is in IP RAN technology. Some of the IP RAN technology has been sold to places, and I don't want to be pejorative because sometimes for any particular place in the world, sometimes the U.S. has brownouts. And so as they have brownouts, some of the links transceivers get browned out unexpectedly. And so I don't know if this is going to help that. I don't know if it's going to hurt, but it is a problem that, the research shows if you're working on convergence and you don't know if things are working right, do you make the IGP signal something more to say that I've got the right topology or warn you? And that may help you in the cases where the link connectivity. You may try BFD, Ketan, sorry Ketan for my mispronunciations, has this other BFD. I'm trying to give color on why some of these problems are important based on some research I was asked to do into some customer problems. So that's comment one. I hope that may help. At least that's the way I understand the need for some of the last couple presentations, because it matches some of the problems that I've reported, and I was asked to look at IGP convergence simulations based on the long-term work that Genghis Luzhnov and other people have done in IGP convergence and how to look at it in simulations. I suspect Tony's simulation has that. Anyway, just a side comment. I hope you don't mind me making that comment where it might be applicable, Waymo.
I think everyone's in violent agreement about this.
Yeah.
You don't have any arguments.
Okay, that's great.
The one thing we'd ask, does what you looked into for this topology, does it support the mechanisms in this draft, the scheduler and...
No, mine is strictly into the problem. Okay. The draft that I've put out is strictly the problem because I wanted to... the first thing was do the problem. I don't know if Waymo's simulation has gone into this with that thing. I won't comment. There are two groups doing research in different solutions. So you may ask Waymo and some of his team on that question rather than me. My first was to do a purely theoretical and then look at some improvements and do some simulation based on aggregation. So I'll point back to Waymo and other places. That's just dodging because I didn't do that particular work. Is that it? Was I clear enough in my caveat to say the theoretical points that it would, that if you don't have consistency, but that's a general well-known problem back to 2000 or 1995. Because we used to have, early days of internet, we used to have the same problem. 1997 we had blackout, half done links. People have found it. Second question is for AC, if I've ended this topic.
Okay.
So most open source implementations that I've worked with, and I'll just say open source and other code bases I've worked with, whether you have a scheduler or not, your code, when you look at it, has an inherent ratio of scheduling for sending out ISIS. When you said, I don't think there should be a scheduler, did you really mean, could you give a little color on that? Because that doesn't really fit, again, the theoretical work from the stuff forward. They always assume you have some sort of range.
Well, he's talking about the distributed algorithm.
Right.
So that would imply, I think the best scheduler is no scheduler at all. That's my opinion for that. Because I think that is a very simple computation, and the problem you really have is the one that Tony was talking about,
right?
With what you do in the transition periods, whether you do a lot or you try and do just the union of the old and the new and do a little. That's more of an issue than the scheduling.
Yeah, it is in the transition, but the self-synchronicity and jitter we once had was to deal with the fact that if you have no scheduler, you can get into the self-synchronicity problem.
So maybe Sue, because AC said none. I was saying something different that maybe applies. What I was saying was I don't think this should be standardized. I'm not saying, listen, if you want to put scheduling in, I mean, and we've got decades of experience, right? I mean, we have ideas about back-off timers, and it's worked just fine for decades for that not to be standardized, right? It's not that I'm not saying, if your implementation needs based on, I mean, this is an implementation thing, right? Like if it's cooperatively multitask or who knows what, right? Like you might have a better timer set up for that particular thing to get the behavior that you're looking for, that I think you're talking about. But it shouldn't be on the wire.
Okay.
No, this is not on the wire. This is just so we assume each node or every node uses the same scheduler. There's no one on the wire.
If you're standardizing what to use, it's on the wire.
Yeah, this one just the option. This one
I saw TLVs, right?
Yeah, TLV is the option.
That's on the wire.
That's on the wire. Okay. I don't want to take too much of the working group's time, but one of the reasons we early on put, and I'm sure the other experts like Leslie, you put jitter in this stuff is to get rid of self-synchronicity, and we're back into redoing some of the algorithm. And, I'm not seeing the same topic reiterating, and I'm just wondering why, both for Tony's algorithm, if there's are we going to get into the big Q calculation, sending out big bursts of stuff, or do we just not have the problem because our interfaces are so fast and our CPUs are so fast?
I think this is an interesting thing to talk about, right? I mean, we're working on it, right? And I think it's interesting to talk about, when links are added, when they're not added, and all of this, right? But when you actually calculate a flooding topology could be a part of that discussion. I just don't see why we have to. I mean, if we want to be agile, right, you don't want to be specifying this stuff, right? On wire protocol. Right?
It would be lovely if we didn't have to specify anything. I mean, less is more in much of the thing. I think the questions, the questions behind some of these desires are what I'd like to see us discuss in the revised thing, because we had the problem in the past. We had the problem of self-synchronicity. As we change these floodings, are we going to get into the same problem? How are we going to handle, most of the FRR does only, if you talk to Leah and the FRR people, what you guys are wanting to do with some of this as well, they only take care of a single link failure. Tomorrow I'll show you where we have multiple link failures that are rolling blackouts. So just a call based on some of what he's doing toward the problem behind it.
So I would like to request for adoptions for this one, because for distributor flooding reduction, and then we have discussion on this for a long time. And then.
So I have a chair comment. We had a lot of back and forth, and we were trying to figure out where things are going and how to move forward. And perhaps something, I think, maybe got lost along the way. My expectation from the outcome of all of our discussions was that this was going to be primarily, your draft was primarily going to be a specification of a standardized distributed algorithm. And what this looks, that's now it's in the appendix of your document. It's not normative. And this instead is talking more about, I think, kind of a generic flooding thing, right? I mean, a generic dynamic flooding thing. For example, I like your FT bits. So if you want to go that.
Yeah,
So this is calling out, possible misconfigurations or problems in the network. This is very valuable information for an operator.
Okay.
Right? But this is work I think that you should be working with, on our now working group adopted document, right? I mean, this should go into the generic signaling that something is broken is a generally useful thing, right? So don't you think that this should go in the dynamic flooding?
No, this is for
Why is this specific to your distributed algorithm?
Yeah, that's a good question. Because for the distributed algorithm, every node will compute the flooding topology, right?
No, on your distributed algorithm.
It's just general.
Because the working group document that we adopted, right, is about signaling either a centralized flooding topology, or it's also for signaling the area leader and the distributed algorithm number. That is the generic document that we're going to use, right?
Yeah,
this was supposed to be about a concrete distributed algorithm, right? If we're going to be in other words, this is the wrong place for this, is one thing I'm trying to say, right? Because we don't want. It's a working group document now, but Tony's draft that we had adopted, right, is the framework upon which centralized and distributed is built on, right? Going forward, we have distributed algorithms need to be standardized. Centralized don't, so that branch is done. But we still have to work on distributed algorithms. That's where that's what I thought was going to come out of your revised draft. And the thing like recognizing that things are broken should, I think, be a more generalized. It's a generally useful thing, right? Why should it just be your algorithm that benefits?
Yeah, that's a good question. So I want to clarify this one. So you mentioned that distributed one, so will receive the instructions from the leaders. So I already described here. So every node must receive instructions from the leader indicated the algorithm.
So there could be you don't expect it to be broken in either the centralized or distributed case. That's why this is good to determine in either case. Because somebody could have trouble, they could not be receiving and installing this in some situations, and installing the centralized topology correctly. Just like the distributed could not work. Both could not work. You expect it to work all the time, and this will tell you if it doesn't. So that's why I think it's generally applicable.
I know. I think it's more cases for distributed one have more kind of this case, and then if you want to generalize, I know it's a distributed one. The centralized one is also possible. I got the idea. But this is more specific to.
But this is supposed to be about an algorithm. You're not supposed to be. We want the draft we adopted to talk about centralized and distributed, right? We don't want. I think that there was definitely. This is maybe my fault, and I will take this because I think I was originally talking about moving distributed out of the thing, and that was not where we landed, right? Where we landed was we have a general framework document with how to signal the information, and then we were going to have distributed algorithms that were standardized outside of that. And I think when we were first talking about it on the mailing list, it was being called the centralized draft and the distributed draft.
Yeah, that's right.
And that's where I think the confusion is. But that's not where we ended up, right? Because the work we adopted up front in order to move forward covers both cases. Right, so it covers signaling for centralized and distributed. So things like this, like the FT bit, not this one, but the FT bit, I mean, this is generally useful. It should just go into the working group's document that covers centralized and distributed signaling, right? Because this is signaling in a generic way about distributed flooding, right?
Yeah, this is because you send the email, you just ask, we remove the centralized one. I did remove the centralized one. I think we should have a distributed flooding reductions, because for distributed flooding reduction,
okay,
we
but
should
you're
have
disagreeing with the process then? I mean, we want one document, right? It's not Tony's document anymore. It's not anybody's document. It's the LSR working group document now, right? Everybody gets credit who works on it. Let's get past that, right? Let's just get work done. And, and everyone should get credit for the work they do. And so that should not be an issue, right? But why would we have two documents saying that? Anyway, I thought we'd all agreed to it. It sounds like there's still some confusion. Maybe we can talk about it offline.
and also I think for the distributed one, there are some specific things. For example, for scheduler, for distributed one, we need a scheduler. For example, for every node, we use same scheduler agreement.
No, but you do not have agreement on that, and that should be discussed on the mailing list. And if for some reason you're able to convince everyone that we should have a scheduler, it should go in the working group document we've already adopted, because it's a generic thing. Unless it pertains, if for some reason the algorithm you come up with that you want to standardize requires this scheduler in particular, then it might be appropriate to go in that specific draft, right?
Yeah, this schedule is we just maybe use the existing one, but just let every node agree and then use the same scheduler. That's the same, because the scheduler already.
Well, if you think it's generally applicable to all distributed solutions, then it should be going into our generic signaling document, right? I mean, not into a separate one, unless you're just proposing it as a way to talk about it before we merge it in. But, again, I thought you were doing a distributed algorithm here.
Hello, I'm Ajun from Trendcom. I have also take part in discuss within mail list for the distributed mode and the centralized mode. As I think the start point and the focus point of the current working draft is for the centralized mode. But in general deployment, I think the distributed mode is more preferred. And so there are overlap for these two documents, and after discussion, we have separated it. And currently, Huemo just provide some issue for especially for the distributed mode. For example, the FT bit. I think it is unfair to put this solution or this issue into the current mode. So I prefer to.
Can you clarify what you said? I didn't understand. Do you say unfair?
Yeah.
But we're not talking fairness. This is it's a standard, right? Developed at IETF.
I know. We are doing the IETF standard work, but for standard activity, I think we should provide some different solution. The first is the centralized, another is the distributed solution.
Yeah, we all agree that the distributed is one of the things we.
All the distributed solutions are coming first from the Huemo's draft, not from the Tony's draft.
That doesn't matter. We're separating the two things. It's not about the velocity, right? We have a framework for signaling, which is not about the algorithms. There's no algorithm specified in that document on purpose, because we want to divorce those two things. We have signaling, which is easy. It's easy to figure that out. It's hard to figure the algorithms out. That's where the work is. That's where the fame is. If anybody wants fame, is to come up with a great algorithm, right? But the signaling is boring work we need to get out of the way so we can work on the hard problems.
Right? I think the signal is easy, but it can be separated very clearly. So I think we should separate the two documents.
So your opinion is that we should separate the signaling from distributed and centralized?
There is no overlap. For some, for FTP.
But why? Because by the way, you're going against the rough consensus of the working group there. The rough consensus of the working group is that it should be combined into a single document. We adopted it on that. So we're probably not going to go back, but Perhaps you have justification.
I did not say we should go back. I think we should go to a different solution. No, there is no current. I know the focus point in the current working group working document is for centralized model. It will flooding the final flooding the final topology. This is.
I think maybe we should take this offline because I need to better understand. I don't understand what your objection is. This is just how we do work in the IETF. We adopt a document. We all work on it. Nobody's not going to get credit for the work they do. We discuss technical solutions. We discuss the problems. We discuss solutions, and we pick the best. We try to pick the best technical solution for the problems that are there. Right? I mean, if we need an FT bit, we need an FT bit. If we need a scheduler, we need a scheduler TLV. None of that. Nobody's saying no to any of this stuff. I'm just saying it's in the wrong place here, right? Because we already have a document for signaling.
Yeah, I think I might give more details. I think in your request for adoption, in your statement is that Tony's draft will focus on the centralized.
I said that was a mistake. I said I made a mistake when I initially said that, and that wasn't what we agreed to at the end of the process. That's not where we landed.
I think the adoption call is based on that one, right?
We need to take that, somewhere else, right? Because it's pretty clear from the email. Tony had sent a mail at some point saying, "I think we're looking at this wrong," and I said, "Yes, you're right. We are looking at this wrong," and everyone agreed to that. At least most people agreed to it. I'm not going to say everyone. Right, but Tony reframed it as this one is about signaling and the other ones are about algorithms, and that was a much more useful way to look at things. And we have tons of agreement on that. So yes, I misspoke originally, and I'll take mea culpa for that. But that doesn't, we're allowed to make mistakes, right?
Yeah, I think that's not good because all the adoption is based on your statement. And then Tony's is focused on the centralized one, and my part is a distributed one. And then you just ask me to remove the centralized one, and then I follow.
It doesn't matter. We're the working group chairs, and we got.
So I follow your instructions, and then remove the centralized one, and then just adapt this one to the your instructions, right?
So you're not happy. I understand, but what we need to do is make the best work come out of this organization.
So happy is not a word to describe my feeling. You see, so this I just express my feeling. So this is a big baby. We have a group of people working very hard to dedicate to this.
Now we're back to credit, and I said there's no issue with credit. Any work that people do is not going to be hidden somewhere, right? If your work is adopted by the working group and we standardize it, of course your name's going to be on it. This is not something we even need to discuss. If some of your work shows up in a document without your name on it, then I think you have something to complain about. That hasn't happened yet, has it?
Yeah, the normal case is that as there's one guy in the mailing list said, so after one document is adopted, it's even harder to people put a new idea in that document. That's a normal case, right? Do you agree or not?
What you're saying is that you think it's going to be too hard to get any new work into the working group document that we adopted.
Yeah, that's normal.
Okay, you know what? This is not LSR stuff. This is IETF process stuff. So why don't we go offline? We can talk to the ADs too if you want.
Yeah. I think we're in a circular discussion here too on this. But so I think we need to take that part of it offline. Are these technical comments everybody's got, not process?
Yes.
Okay.
Les Ginsberg. So full disclosure, I'm a co-author on the draft that was adopted. But the comment I would make in regards to the FT bit, without commenting whether it's a good idea or a bad idea, but operationally it overlaps with the definition of how we signal temporary flooding. And so if we're going to decide that this is a good idea, I think we have to take those two mechanisms and decide how to signal it and get both out of it if that's what we think is the best solution, which is why it needs to be in the same document.
Yeah, I think this is different from those kind of request bit. So request bit means that we send a request to the remote site, and then we request this link to temporarily add a flooding topology. This one just I compute flooding topology regarding to this link. This link is on the flooding topology. So just this is two different things.
Tony Lee, Arista. So the way we make progress in the IETF is we make proposals. If you want to move forward with this, the right thing to do is to send mail to the mailing list proposing your idea. We then discuss it on the mailing list. If we agree, we then incorporate it into the document. I have no objections to your idea. Let's talk about it. Okay. That's enough.
Yeah, regarding to discussion, I think when the proposal to deliver two document, I think someone, I remember maybe Robert, proposed that as long as the centralized one send a signal to the distributed one, and the distributed one can do the distribution by themselves, right? You right? I don't remember. We can check that on the list.
Maybe it'd be time to take this offline and talk to the chairs and the AD. It's just a suggestion as a chair that the best way forward is that.
I think this whole process. Anyway, so we'll discuss these two mechanisms as generalized mechanisms. As the scheduler, which I agree that if you're going to do a scheduler, you don't need to disseminate the timers unless you're doing distributed. But for the FT bit, we can discuss those two. We'll discuss those two independently, okay? Okay, thank you. Hey, luckily we're a little bit early, but we're going to meet again tomorrow, and I would advise people to read the drafts giving priority to the two. We're talking again about the two rather radical extensions to ISIS. I'd recommend everybody read that. And the other one, if you have time, I'd recommend you read Sue's document on the use case. That's going to be tomorrow as well. The other two, I got a Yang model. I can explain. You don't really have to read it. I can explain it in the 10 minutes I'm going to talk about it. So it's not, well, you don't have to read it. There's only so many hours before the next meeting anyway. And the one on TE, we're going to have that presented, maybe have some comments, but we're going to move it to the T's working group, the one on packet slicing using segment routing, because it really didn't belong here, but we got the request late, and I didn't really read it till the plane, and I said, well, this doesn't belong here, but it wasn't scheduled in T's. We had time. We're going to leave it on we decided to leave it on the agenda. It does have some minor TE extensions in it, but that's the small part of the draft relative to the framework that is being proposed in that one. So maybe I got you curious enough to read that one as well.
By the way, earlier, since we got a little heated there, if everyone would go to the Etherpad, that's where we're doing our minutes. Let's make sure we captured everyone's comments, right? Because it's not always easy to understand each other, and if we put them down in the minutes, maybe it'll help move that process forward. So make sure that your comments were there and captured correctly. We don't want to miss anybody's opinions.
The discussion in the end happens too fast, too quick. So I only captured maybe 60% of the whole discussion. So please go on the Etherpad and fill in whatever you said.
Okay. Thanks, Ying Zhen. Okay.
Thanks, everybody. See you tomorrow.
Tomorrow, yeah.
No, and it's like it's used like we're not a journal. We're not a scientific journal. This is kind of If anybody hadn't signed the blue sheets, grab it on the way out.
It's good when that aligns, but that's not the goal. The goal is great. And so he's like, you could have software that whatever. I'm saying that's it is. And your software, basically, you're saying you don't get so fast. And all I'm saying is, well, in case you're thinking so slowly, if you need it, that's something you should be figuring out. Not somebody should be telling you. Because you know better than them. Right?
Yeah, you know what your software is.
Exactly. So I was sort of pulling into comment about certain software. There are differences. Well, that's all the reason you shouldn't standardize. You still want to, yeah. I really want to email. Hey, what time is this supposed to end?
We'll talk about. It's supposed to talk about till 20th.
20th. Okay. So I kind of feel like I should do it. But for Wemo or whatever. But yeah, we'll talk about it. Who does what? I mean, I can't believe I just need to compare. I hope they that is the reality. That is the reality is that someone can do that now you're I know, but I feel like I wouldn't like
Hey, can we take 2 minutes of your time to discuss the anthropological stuff?
Yeah, I agree to single. I was going to send it back. That's my thing. I agree we should just do it one way.
I felt like I was like digging a hole there.
It was the external case. The issue is, should we combine?
What do you mean by this?
If we're changing this encoding, should we combine the two drafts? I don't know.
I mean, I wouldn't necessarily object to that.
Yeah.
Right now, we're not moving on either draft.
I know. Yeah.
So let's figure out how to move.
Well, we need to get the pen. You don't have the pen.
No.
You're the, but yeah. So.